Okay, so today we're going to learn factoring pattern for a trinomial that looks something like this. 1 x squared plus bx plus c. Okay. So far, how many ways have we learned how to factor? Very first method was always look for GCF is correct. And last time, what did we learn? We learned how to factor. What? Say again? Difference of squares. Now, difference of squares should be a dead giveaway, right? Because you have to have how many terms for difference of squares? 2 terms. And you have to have something either side of this, something squared, right? That's why it's called difference of squares. Does that make sense? So if you have trinomial, it's probably not a difference of squares. Does that make sense? You have to have two. You have to have binomial with subtraction in the middle where each terms are squared, right? Does that make sense? But now, what if you could have, now today we're going to learn how to factor a trinomial now that looks something like this, where the coefficient of the, which term is this called? X squared term? This is the quadratic, remember? If the coefficient of the quadratic term is 1, that's the only one. So write this down. Today's pattern only works for trinomial with coefficient of the quadratic term is 1. Otherwise, it will not work. Okay, so this is a very specific type of a trinomial. Does this cover every possible trinomial? No, it doesn't. Only trinomial with coefficient of the x squared term is 1. Keep that in mind. Does that make sense? So this pattern, the way we're factoring this, only works if you have coefficient of the x squared is 1. Otherwise, it will not work. So then how do we do with coefficient that is not 1? Well, that's coming up later. Okay. So like I said, if you go ahead and watch my video, it's all there. Over the weekend? Or over the break? No? Okay. Anyway, so write this down. So just like last time, you know how we started off with, Paul, when for the difference of square, we kind of looked at backwards, right? Last time I multiply a plus b times a minus b, and we noticed that every time you multiply a plus b times a minus b, you get a squared minus b squared. And we noticed that pattern, right? To factor, if you have a squared minus b squared, it's always going to be a plus b times a minus b. So we're going to do the same thing here. Why don't you multiply these two binomials? And let's see whether we can figure out the pattern. First one, x plus 3 times x minus 5. The other one, x minus 6 times x minus 4. And we're going to try to look at the pattern. Show all your work, okay, because that's important. Multiply it out and let's see whether we see the pattern, okay. What did you get for 1? Yes, sir. Paul?
X squared plus 8x plus 15.
Plus 15? That's what I got too. What about b? Didn't you get this? No? You get x times x, you get x squared. X times plus x times 5, you get 5x. 3 times x, you get 3x. 3 times 5, you get 15. Right? What about the next one? B. Yes, Ryan, what'd you get?
I got x squared minus 10x plus 24.
That's what I got too. Okay. X squared minus 10x plus 24. Okay, so now we're trying to if I were to give you, if I gave you this trinomial, will you be able to tell me that this was x plus 3 times x minus 5? If I gave you this trinomial, will you be able to tell me that this is x minus 6 times x minus 4? That's what we're trying to work on. So let's see if you see any pattern. First of all, notice the coefficients of the x squares. They're both 1. How do we get x squared? What do the binomial must look like in these first 2 terms? They have to be, in order to get x squared, they both have to be x and x. Isn't that right? Are there any other ways for this to be x squared? What if there were 2x and half x? Don't you get x squared? Right? But when we factor, we only factor so that these coefficients are what kind of numbers? Not one. Integers. We want them to be integers, right? We don't want them to be fractions or decimals. So we don't have to worry about that one, right? Where x is 2x and then the other is half x. Then you get x squared. So the only way for you to get x squared is if the first 2 terms of the binomials are x and x. Does that make sense? Now look at how we got 15 here. Oops. How did we get 15? It was? Yeah.
3 times
3 times 5. That's how we got 15. How did I get 24? It was is it 6 times 4 or is it negative 6 times negative 4? Negative 6 times negative 4. That's right. Do you see how we get the last term? I want you to think about that. You just multiply the last numbers together, you get the last term. What about the linear term? How do we get 8x? That's the important part. Hmm? You do what? You're right. I just didn't hear. You add the integers. Which integers? 3 and 5. Have you noticed? Look. 3 plus 5, what's that? 8. You see, it gives you the coefficient of the linear term, doesn't it? But what about this? How come I got negative 10? Isn't 6 plus 4 10? How do I get negative 10? William?
They're both negative.
They're both negative. So you should think of this as x plus negative 6 times what? X plus negative 4. What is negative 6 plus negative 4, guys? Negative 10. It gives you that coefficient of the linear term, doesn't it? Now, does it work for every trinomial? No, only if the trinomial has 1 as its coefficient for the quadratic term. Does that make sense? Hello? Okay. So, but before we get to that, so we're going to factor in a minute, but I want you to kind of multiply this vertically. Is there a way to, okay, let me, hold on a second. So do you see how we have b? Is it okay to multiply this vertically? You know, like x minus 6 times x minus 4? This is going to be really important. So, first of all, let's multiply this vertically by writing this as addition. Does that make sense? Okay, so let me erase these. Let's do this together. So I write this as addition. And I get here x plus negative 4. Is that okay, guys? And so, first of all, how do we get x squared here? We multiply x times. So rather than doing rather than multiplying them with these arrows, I want to multiply them vertically. So we did x times x, right? So here, guess what we're going to do? X times x this way. Is that okay? What do you get? X squared. Then, what do we multiply? X times? Didn't we do x times negative 4? Not 4. X times negative 4, right? So what do you get when you do x times 4? What is that going to be? Yeah, plus what? Plus negative 4 what? X. Very good. And of course, didn't we then multiply negative 6 times negative 4? So you're going to do negative 6 times negative 4. What do you get? Plus negative 6x. And lastly, we multiply negative 6 times negative 4, which is 25 or 24? 24. So we should simplify this, right? Don't we get then x squared? What's this? Plus, what is negative 4 plus negative 6x? Negative 10x, which is what we had before. Plus what? 24. So, do you understand how I multiply vertically? Yes? Why do you think I did it this way? Because this is kind of nice to see how we multiply these binomials vertically. Anybody notice? Look, hint, look at the red ones. How do we get the linear terms? First of all, watch this. When I look at these vertical multiplication, what's x times x? I got the quadratic term. What about the last one? It's negative 6 times negative 4. I got the constant term, right? How do we get the linear term? When you multiply them, what? Across. What the diagonals gives you the linear terms, doesn't it? Do you all see that?
Yeah.
So that's going to be really important. Keep this in mind. So when you multiply this vertically, the vertical ones gives you the first and the last term. The diagonals gives you the middle term, the linear term. Does that make sense? Keep that in mind as we go on to the next example. Are we good with that? Okay, you'll see why I did it this way, because this is really important. It's important to understand that when you multiply them vertically, the diagonals gives you the linear term, the middle term. Okay? Keep that in mind. You'll see why I did that in a minute. So let's take a look at this. Now we're ready to factor this trinomial. And thankfully, look at this trinomial. My first coefficient, or the coefficient of the quadratic term is what? No, that's not the coefficient. What's the coefficient of the quadratic term? It is 1. So we know how to factor this now, because we noticed that Well, so let's write this vertically. So it's going to be something, some binomial times another binomial. Would you not agree? Isn't that how we get trinomial? Binomial times binomial gives you trinomials. Not every time, but most of the time. When do we not get trinomial? This is from last time. When you multiply binomial times binomial, there are times where you get binomial. When's that? Yeah.
When you have like the binomial like plus and like multiply by
Yeah, like with the difference of squares, right? But all the other times you get trinomial. Okay? So, by the way, how many ways are there to get x squared?
one.
So guess what? Well, this has to be x and the other has to be x, right? Are there any other? Actually, there is other case.
Squared and one.
Oh, 2x.
No, you can't have x squared and 1 because you have to multiply binomial times binomial to get. 2x times 1/2, yeah, but we said we don't have to worry about that one because all the coefficient must be integers. There's another case that we haven't thought of. What about, yeah. No. So when you multiply these two terms, you have to get x squared, right? Is this the only case where you have to get x squared? Does it have to be x and x? There's actually another case. Yeah.
Isn't it x squared and 1?
I'm sorry?
Is it
No, if you have x squared and 1, you're not going to get this middle term. There's no way you get, right? Yeah.
negative x and
Thank you. Negative x and negative x. Doesn't negative x times negative x give you x squared? But we don't have to worry about that one for now. Let me explain that later why. You're exactly right. I could actually have negative x and negative x. Okay? But it turns out if I have that, there's always a way to simplify that later. Okay? So don't worry about that one. Okay? So just think about positive case for the first term. Is that okay? So in order to get x squared, for now, there's only one way. X times x. Is that okay? Now, but then what about these two? When you multiply these two, you have to get what, guys? When you multiply these two vertically, you have to get the constant term, right? So how many ways are there to multiply two numbers and get 28? Are there, yeah, first one, what's the easiest one? This is what I'm thinking in my head.
well, there's
So tell me 1 and what?
21
20,
28 times
1,
1.
1 and 28, right?
Yeah.
If I have 1 and 28, what else could I have? Negative 1 and negative 28. Of course that works. Doesn't that give you 28? Is this the only case? Because it could be 1 and 28 and, right? What about 2 and 14? If I could have 2 and 14, what else could I have? Negative 2 and? Negative 2 and what? Negative 14. Is this the only way? Are there any other? How about? Does 3 go into 28? No. What about 4 and 7? If I could have 4 and 7, what else could I have? Negative 4 and? And now at this point, it's kind of like a multiple choice. Which one of these pairs do you think will go in here? So that now, this is why I did this vertically multiplication. Remember, how do we get the linear term, guys? You do the what? The diagonals gives you the linear terms, doesn't it? So which number do you think will go in? I can already see that 1 and 28 will not work. Because if I were to plug in 1 and 28, I get 28x and 1x. That would not give me 16x, would it? Which one of these do you think will work? See, at this point, it's like a multiple choice now. Multiple choice. Yes, what do you think?
2 and 14.
You think 2 and 14 will work? How many people agree? 2 and 14. Very good. Could I write 2 and 14 or 14 and 2? Does it matter, really? It doesn't matter. I'm going to write 2 and 14. Do you see why this vertical multiplication is kind of nice? You can see when you get the linear terms by looking at the diagonals. Does that make sense? Do you think we should check this? See if we got it right? Yes, always. So what do we get? What's x times x?
x squared.
X squared. Plus, what's x times negative 4, guys? X times 14. 14x. So I'm going to do that in red. The diagonals. Is that okay? 2 times x, what do I get? 2x. And I could see it's going to be 16. And then lastly, 2 times 14 I get? 28. So let's simplify it. I get x squared plus, what's 14 plus 2x? 16x plus 28. Do all of them check? How many things do we have to check? How many terms do we have to check? All 3 terms, right? Do we get x squared? Yeah. Do we get 16x? Do we have 28? Yeah, so therefore we know how to factor. What's the answer? Let's write down the answer right here. How does this trinomial factor to? What's it factor to? Yes?
X plus 2 times x plus 14.
Thank you. There's your answer. Do you see why I did this vertically this way? Yes? You could see that the diagonals give you the linear terms. Because that's kind of the important one, right? Because there's so many ways to get 28, right? Which one do we choose? Well, if you see that the diagonals would give you the linear terms, right? The middle term, it's kind of easy to see which one to pick. Does that make sense? So once you write these things, it's kind of like a multiple choice. You have to choose the one that works. Okay? Any question?